Hi guys, welcome back to YouTube channel Chemistry Live UGPG. Today we are going to talk about alcohols, phenols, ethers and epoxides. CC6 paper, Unit 2, Lecture 5. So this will be highly useful for BSc Chemistry students under CBCS syllabus. So I have a simple message for you guys. Please think for innovation, be creative, learn everywhere, anytime and help to learn others. So today we are going to talk about Reimer Tiemann reaction, Kolbe Schmidt reaction, Fries rearrangement and Claisen rearrangement with mechanism. So what is Reimer Tiemann reaction? So phenol react with chloroform in presence of potassium hydroxide. So it gives rise to salicylaldehyde. So let's talk about how this reactant phenol is converted to salicylaldehyde. So that is called mechanism. So this is the structure of a CHCl3. So potassium hydroxide OH minus ion will take this proton and this CH bond will break on this carbon. So you can have CCl3 minus. So again this compound is unstable, so it will lose Cl as Cl minus. So you can have this carbene CCl2 carbene. So what happens? Again the phenol react with potassium hydroxide, you can have this oxyanion. So this when this O minus will come back, so the pi bond here will attack to this carbene CCl2. So you can have this intermediate. So here this C minus will take this proton and this CH bond will come here and this double bond will break on oxygen. So you can have this oxyanion. So here this O minus will take this proton. So yes, so this intermediate would react with potassium hydroxide. So one of the Cl will be converted to OH. So this O minus will take this proton and this O bond will come here and it will kick out Cl as Cl minus. So you will end up with salicylaldehyde. The next is Kolbe-Schmidt reaction. So phenol react with carbon dioxide in presence of sodium hydroxide, giving rise to salicylic acid in presence of sulfuric acid. So phenol upon reacting with sodium hydroxide OH minus ion, so you can have phenoxide ion. So when this O minus will come here, the pi bond here will attack to this carbon and double bond will break on oxygen. So you can have this structure. So here the loss of a proton again. So this H bond will come here and this double bond will break on oxygen. So here revival of aromaticity. And upon treatment with hydronium ion, so this O minus will take the proton, you can have salicylic acid. Next is Fries rearrangement. The rearrangement of a phenolic ester to a hydroxyaryl ketone by catalysis of Lewis acid. So this is known as Fries rearrangement. So this is the phenolic ester upon treatment with Lewis acid, let's say aluminum chloride. Okay, so you can have this orthohydroxyketone or you can have para-hydroxyketone depending upon the temperature. So at low temperature orthohydroxy is the major product and at high temperature para-hydroxy is the major product. So here is the mechanism. So this is the phenolic ester. So oxygen lone pair will attack this AlCl3 Lewis acid. So you can have this intermediate. So here oxygen lone pair will attack to this aluminum and this bond will break on O plus and CO bond will break on oxygen. So you can have this intermediate and RCO plus carbocation. So here oxygen lone pair will come here and this pi bond will attack to this electrophile RCO plus. So you can have this intermediate. So here again simultaneous bond breaking and bond making takes place. So this Cl will attack to H plus and this bond will come here and this double bond will break on O plus. So you will have this intermediate. So upon treatment with water you can have this orthohydroxy derivative. Similarly, when we have para product, so here O minus, this O will come here and this pi bond will come here and this pi bond will attack at para position, it will attack RCO plus electrophile. So you can have this quinoid type structure and loss of again this proton lead to revival of aromaticity, so giving rise to para substituted product. Similarly, this reaction can occur intramolecularly. So oxygen lone pair can attack AlCl3. So here you can have this structure, and here again you have a rearrangement. So this bond will come here and this pi bond will attack to this carbonyl. So you can have this structure. So again this Cl will attack to this proton and this bond will move here and this double bond will break on O plus. So you can have this structure, which upon treatment with water you can have this ortho substituted product. The next is Claisen rearrangement. The heating of an allyl vinyl ether will initiate 3,3 sigmatropic rearrangement to give a gamma delta unsaturated carbonyl compound. So here you can have this allyl vinyl ether, so it will undergo 3,3 sigmatropic rearrangement, giving rise to this gamma delta ketone or unsaturated carbonyl compound. So here this is the compound. So here it can undergo 3,3 sigmatropic rearrangement. So you can have this structure. So loss of this proton again will revive the aromaticity. So you can have ortho substituted phenol. So there is inversion of the allyl group during the rearrangement. So please subscribe to our channel Chemistry Live UGPG. And for class 11 and 12 students, they see the channel Foundation Chemistry AV. So this is a simple step towards e-learning, making life better. Thank you for learning.